Hi everyone, once again welcome back to our class. Now we are going to discuss about the motion in a straight line, some equations, kinematic equations of motions, 4 equations, some relations between displacement, velocity, initial velocity, retardation and etc. Now first of all, here question is here equation of motion for a body moving with uniform or constant acceleration along the straight line. Now the body moving along the straight line with uniform acceleration. So the 4 equation of kinematic equations here. First equations, these equations changes from different methods. So some values here constant, then the relation between remaining terms. Okay, here first of all equation, first equation, okay, v is equal to u plus at. Here second equation, kinematic equation, s is equal to u t plus half et square. The third equation, third one, this one here, b square minus u square is equal to 2as. Fourth one also here, fourth one, Sn is equal to u plus a by 2 2n minus 1 or here Sn is equal to u plus a into n minus 1 by 2. These are kinematic equations. These are here kinematic equation. Now these relations sum in between any two terms in law. ఇక్కడ చూసినట్టయితే ఈ ఈక్వేషన్స్లో ఎలా చేంజ్ అవుతుందో చూద్దాం ఒకసారి. వెన్ ఏ పార్టికల్ మూవింగ్ ఫ్రమ్ రెస్ట్ or starting from rest, moving with constant acceleration along the straight line. For example, for a particle starting from rest and moving along the straight line with constant acceleration, then these equations converge and the relations in between some two terms, two here values. ఇక్కడ చూడండి, these are kinematic equations of motions. Here first condition, here for a particle starting okay, starting from rest and moving with or traveling, okay, moving or traveling with uniform acceleration along the straight line, along the here straight line. Then above equations, ఇక్కడ ఏంటంటే the particle starting from rest, that means here initial velocity here 0. Once again see here, ఇక్కడ these 4 equations converting into some relations, remaining terms here for a particle starting from rest. This is a rest ante initial velocity here 0 and traveling with uniform acceleration along the straight line, that means here above equations converted in 4 equations. Initial velocity, that means here initial velocity is 0, first equation and second equation, third equation, fourth equation, these relations. Now first of all note this one here, this is a initial velocity starting from rest, that means here initial velocity is a 0, above equation conversion. Now here first equation, first one, here initial velocity 0, that means the particle moving from rest, that means here u is equal to 0, here 0, condition here u is equal to 0. First equation v is equal to u plus here at. So u is equal to 0, that means here 0 plus here at. A is a constant, So the particle moving along the straight line with uniform acceleration or constant acceleration. Here A is a constant. Here A is a constant. So the relations, this is a constant. So V is equal to 80. A is constant. Here A constant. A is here constant. That means here relation velocity directly proportional to here time. Velocity directly proportional to here. So here a velocity and time relations. This is a velocity time relation. So velocity is velocity of the particle is directly proportional to time. That means the compare the two velocities in two times. Here v1 by v2 is equal to here t1 by t2. This is a relation. Okay, first relation, the velocity time relation. Next case here, s is equal to ut plus of at square. So here u is equal to 0, simplifies. Second one, here s is equal to 0 into t plus of at square, simplifies. Here s is equal to of at square. So a is a constant. That means here simplifies a is directly proportional to here t square. S directly proportional to t square. That means displacement of the particle and time. These are relations. These two relations between time and displacement. So are the relation compared to the two displacements. అంటే ఏవైనా రెండు సారాంశాలను పోల్చినప్పుడు ఇప్పుడు ఇక్కడ చూడండి, s1 by s2 is equal to here t1 by t2 whole square or here t1 by t2 is equal to under root of here s1 by s2. This is a relation, time displacement relation. This one here time displacement relation. Next one, third equation of motion. And third one here, v square minus u square is equal to here 2as. V square minus u square is equal to 2as. Okay, now u is equal to 0. Above equation here, v square is equal to just to 2as. S is a displacement, a uniform acceleration, that means constant acceleration, v final velocity. So a is constant, 2 is a constant. Then the relation between time and displacement. That means here v square directly proportional to displacement. That means square of the velocity is equal to square of the velocity is directly proportional to displacement of the particle. Here relations, this relations displacement and velocity. This relation here displacement and velocity. Now ikkada simply here relations compared to the two velocities and two displacements. v1 by v2 square is equal to here s1 by s2 or v1 by v2 is equal to under root of here s1 by s2. This is a third equation. Okay, this one third, this one here second one, this one here first one. Okay, here under root s1 by s2, this is this relation velocity displacement time, this relation here time displacement. So the comparison అయితే మనకి velocity and time, this compared to first equation. Okay, under root of s1 by s2, this compared to the s1 by 2 is equation 2 is equal to equation 3, that is equal to, for example, this relation from 1 2 and 3 ఇక్కడ ఏంటంటే this is equal to this also v1 by v2 is equal to t1 by t2. This relation is here first equation, this one here first equation. Okay, this is a first. ఇక్కడ 3 equations. First equation relation velocity time, here second equation relation between time and displacement, your third velocity and displacement. Fourth one చూసినట్టయితే here fourth one, note this one first of all. Okay, very important concept oriented problems remaining after some problems. Okay, note this one first of all. Here fourth equation, fourth Sn is equal to, fourth one here Sn is equal to, here fourth one Sn is equal to, fourth equation Sn is equal to here, this is the fourth, u plus a by 2 into 2n minus 1, 2n minus 1. So in this formula here u is equal to 0, u is equal to 0. So Sn is equal to 0 plus a by 2 into 2n minus 1, 2n minus 1. So here a is a constant, so the relation here Sn is equal to, the relation Sn directly proportional to here 2n minus 1, 2n minus 1. These are 4 equations. This relations here n times and ikkada displacement, n times displacement. So this is a 4 equations. Now this case, the relations, the particle starting from rest, moving with uniform acceleration or constant acceleration, then along the straight line, then the 4 equations, these 4 equations. So next one here, next one, the particle moving with uniform velocity, uniform velocity, okay, along the straight line, along the straight line, then the acceleration of the particle is 0, the acceleration of the particle is 0. అంటే ఇక్కడ పార్టికల్ అనేది యూనిఫామ్ వెలాసిటీతో మూవ్ అయినట్టయితే దాని యొక్క త్వరణం అనేది 0 అవుతుంది, దాని యొక్క త్వరణం అనేది 0 అవుతుంది. దెన్ ద అబోవ్ ఈక్వేషన్స్, దట్ మీన్స్ హియర్ the above 4 kinematic equations. Note this one first of all, some relations problems చెప్తా. Okay, here now for a particle here, second case here, for a particle moving with uniform velocity, along a straight line, along a straight line, when then its acceleration will be 0, acceleration will be 0, okay, will be 0. That means here a is equal to 0. Now above equation nothing but here 4 kinematic equations. ఇక్కడ 4 ఈక్వేషన్స్ చూసినట్టయితే మనకి ఫస్ట్ ఈక్వేషన్ ఇక్కడ కండిషన్ యాక్సలరేషన్ a is equal to 0, కండిషన్ here యాక్సలరేషన్ a is equal to 0, here velocity is a uniform velocity. Now above equations here, first equation v is equal to u plus at. So a is equal to 0, that means here v is equal to u plus 0 in nothing but here 0, here v is equal to u is equal to here v is equal to here u. That means the final velocity that is equal to initial velocity. This means here final velocity that is equal to here initial velocity. So starting velocity and final velocity both are here, in this case here same. Second case here, second one, s is equal to ut plus of at square. So in this case acceleration is a 0, okay, here a is equal to 0. Now above equation here displacement is equal to u plus ut plus here 1 by 2 into 0 t square, 1 by 2 t square. So this terms totally 0. So simplifies here s is equal to ut, here ut. This is a third condition. In this case here u is constant, u is also constant, here a is 0, u is constant, means the particle moving with the uniform velocity. That means here initial velocity is equal to here final velocity. This is a constant, so here u constant, u is a constant. So the relations, this is a constant, u is a constant, so relation, so displacement and time, relation here displacement and time. So simply compare to the two displacements, okay, here s1 by s2 is equal to t1 by t2. This is a relation between time and displacement, Here next case here, third kinematic equation, v square minus u square is equal to here 2as. Here in this case here final velocity that is equal to initial velocity, both are here same. So here displacement here చూసినట్టయితే 0 వస్తుంది. ఇక్కడ ఏమొస్తుంది మనకి a is a 0, a is a, so totally this one here s is equal to 0 అవుతుంది displacement here. So relieve it. Next case is here there is no relations. In this case here fourth one Sn is equal to u plus a by 2 into 2n minus 1. So here u is constant, a is 0. So in this case here Sn is equal to some 0. Sn is equal to here, so 0. Next case here, now this one first of all. Okay, now the particle, for a particle moving with uniform retardation along the straight line, okay, the distance covered by the particle before coming to rest above, then the above four equations here for a particle, third one here, for a particle moving with uniform retardation, retardation along the straight line, uniform retardation along the straight line, then here the distance covered by the particle distance covered by distance covered before coming to rest, before coming to rest, okay. That means here final velocity is equal to 0. ఇక్కడ చూడండి, here see here for a particle moving with uniform retardation, so uniform retardation negative, okay, along the straight line, then the particle distance covered before coming to rest, that means here final velocity will be 0, initial velocity. So first equation v is equal to u plus here at, this is a retardation acceleration, it means here retardation negative acceleration. So here in this case here this is a 0, so here a is a constant, uniform retardation, a is a constant, so u is equal to u minus at, here a is equal to minus a, so negative symbols, retardation. So simplifies here u is equal to just to okay, sorry, u is equal to here at relation u directly proportional to t, so initial velocity and time relation, so here simplies u1 by u2 is equal to s1 by s2, this is the relation between initial velocity and time, second equation, second one here, s is equal to ut plus of at square, okay, of at square. In this case here, now a is constant, displacement, and here this is u is a initial velocity. So third one ఇది. Note this one first of all. Okay, this is a no change, displacement to initial velocity, time and acceleration. This is a there is no change. Next one, third equation here, third v square minus u square is equal to 2as. This is a change relation between here initial velocity and displacement. Here in this case here final velocity is a 0, so the before coming to rest after some time, that means here final velocity of the particle here v is equal to 0, so v is equal to, substituting here v is equal to 0, 0 square minus u square is equal to minus 2as, so minus symbol means the acceleration is a retardation, acceleration, so that means here minus u square is equal to minus 2as, so okay. Now a is constant, uniform retardation, that means here relation minus get cancel, implies here u square is equal to 2as, so displacement s is equal to u square of the initial velocity by here 2a, square of the displacement square of the initial velocity by 2a. Here a is constant, and that means a retardation, that means here retardation, deacceleration, so that means a is constant, 2 is constant, so relations here displacement directly proportional to your initial velocity, displacement of the particle is directly proportional to square of the initial velocity. That means here the relation here s1 by s2 is equal to here u1 by u2 whole square, so this is our initial velocity 1 by u1 by u2 is equal to under root of here s1 by s2. This is these are relations. So these relations very important complicated problems in JEE Mains and Neat. ఈ ప్రాబ్లమ్స్ మనకి JEE Mains నీట్లో అడగడానికి సింపుల్గానే ఉంటాయి, కానీ అప్లికేషన్ చేసేటప్పుడు కొద్దిగా ఇబ్బంది పడతా ఉంటారు, కాబట్టి దాన్ని దృష్టిలో పెట్టుకొని ఎక్స్ప్లెయిన్ చేసిన. ఓకే, చూడండి దీనిపైన మనం నెక్స్ట్ క్లాస్లో ప్రాబ్లం చేస్తాం. ఓకే, థ్యాంక్ యూ, ఆల్ ది బెస్ట్.